is the physics doesn't change, right? So you shift your whole experiment from here to there, you get the same equations of motion. And the equations of motion, if you know anything about like Hamiltonian or Lagrangian mechanics, these equations only depend on the derivatives of your position, how your position changes with time, not the actual value of the position, right? And so if you take your position and you add a constant to it, x goes to x plus a, then the derivatives don't change, because when you take the derivative, a disappears. The equations of motion you get when you shift your position don't change, because the equations of motion only depend on the derivative. And the derivative of your position is your velocity, which is closely connected to your momentum. That's sort of like a sketch for why the symmetry in position gives you conservation of momentum, because the equations of motion only depend on the derivative of the position, not the position themselves. Conservation of momentum comes from the fact that space is the same everywhere. If you shift your experiment from here to over there, you don't get a different answer. That's why momentum is conserved. Symmetry, right? There's always some symmetry which produces a conservation law.